Today's lesson is on tangent line approximations, and the goal of this video is to use a simple function such as a line to approximate a more complicated function. The idea is if you have a function, let's say this is f of x, if you can draw a tangent line at some point C, so here's the point C and here's my tangent line. Obviously at this point C, the function and the line, which we'll call L of x, have the exact same value. But if f of x is a complicated function, so let's say I pick a point very close to C but a little bit further to the right, obviously the value of the function and the value of the line are going to be different, but as you can see, those y values are very similar. So if I can come up with the tangent line, I can come up with a decent approximation to the function as long as the point of tangency is very close to that value you're trying to approximate. You can see as I get further and further away from that point of tangency, the approximation is going to get worse and worse. So we're going to use a simple function like a line to approximate the y value of a more complicated function. So the first example that we'll look at is f of x is cosine of x. So the question is, find the equation of the tangent line at x equals 0. So anytime you hear those words, tangent line, you should be thinking I need a point. The x value I give you is 0, the y coordinate is 1, and I need a slope. My slope is my derivative, which happens to be negative sine of x, and my slope at x equals 0, if I plug in 0, is 0. So the equation of this line happens to be y equals 1. And this should make sense graphically because if you think about the graph of the cosine graph looks something like this. Oops. And it goes on infinitely. And at x equals 0, your tangent line is just the horizontal tangent y equals 1. So at exactly x equals 0, they share the same point. But the idea is, let's say I wanted to figure out what cosine of 0.05 is. Without a calculator, there's no way to know what that value is, but 0.05 is very close to 0, so I can say it's approximately whatever the value of the line is, which is about 1. If you actually use your calculator to punch this out, oops, 0.05, cosine of 0.05, sorry. Cosine of 0.05 is exactly 0.99875. So this is the approximation from the line. This is the exact value of the function. The difference would be the change in f of x minus L of x. Let's try another one. So let's try, this time the function is 1 plus sine of x. So I want you to come up with the tangent line at x equals 0. So again, I need a point, which is 0, 1 again. The slope is the derivative, which is cosine of x. If I plug in x equals 0, my slope is 1. There's my point, there's my slope. My equation looks like this. Y minus 1 equals 1, x minus 0, which you can write in this form if you want. So there's the equation of the tangent line. So if I say approximate, and I'm going to call this L of x for right now, if I say approximate the value of the function at 0.05. Again, this only works for values very close to the point of tangency, which in this case is 0. So 0.05 is close to 0. So if I plug in 0.05 here, the value of 1 plus sine of x is approximately 1.05. And if you type it into the calculator, you should be very close to that value. Let's look at a couple other types of problems. So now let's say I ask you to approximate 0.998 cubed without a calculator. So the idea is, let's first identify the function in this problem. Okay, I am taking a number and I'm cubing it. So here's my function. And what you want to do is find a c value, which is really your x value, very close to 0.998 that you can work with easily. 1 is very close to 0.998. I can cube it out pretty easily. So this is your x value, and this is your function that we're going to work with. So again, I'm going to do the same thing. I'm going to come up with the equation of a tangent line. I need a point. Here's 1. 1 cubed is 1. I need a slope, which is my derivative, 3x squared. At x equals 1, my slope is 3. Write the equation of the tangent line. Y minus 1 equals 3 quantity x minus 1. Okay, so I'm going to rename this as L of x, and if I multiply this out, I'm just going to leave it like this. So there's the equation of the line. So the idea is, okay, I don't know what 0.998 cubed is, but I can figure out what L of 0.998 is, and we can do this without the calculator pretty easily. So 0.998 minus 1 is negative 0.002. 3 times negative 0.02 is negative 0.06. Add 1, you're going to get 0.994. So this is your approximation for 0.99 cubed. If you actually type in 0.998 cubed in the calculator, it's 0.994,01192. So notice that the tangent line gives us a pretty decent approximation because we use the number very close to that point of tangency. Okay, let's try one more like this. Let's try same thing, but this time let's try trig one. So if I ask you to approximate cosine of 31 degrees without a calculator, okay? Again, we're going to identify the function. The function is cosine of x. The value that I want to use for c is going to be 30 degrees. 31 degrees is very close to 30. I want to be close to that point. I want to be very close to this point, so I don't want to use 0, and 30 is a value that I can do the trig. I know the trig values pretty easily. So what do I need? I need a point. So my point is pi 6, comma, cosine of 30 degrees is root 3 over 2. There's my point. My slope is negative sine of x at 30 degrees. There's my slope. So y minus root 3 over 2, quantity x minus pi over 6. My equation of the line is x minus, oops, I forgot the negative 1/2 in the front here. Negative 1/2 x minus pi over 6 plus root 3 over 2. So I'm going to use the line to approximate the value of the function. So L of 31 degrees is negative 1/2. And instead of changing 31 degrees to radians and then subtracting the pi 6, this is really 31 degrees minus 30 degrees, which is 1 degree, which I know is pi over 180. So without a calculator, you would leave your answer like this. So this would be the approximation. If you punch it out, it's actually 0.8572 something. The actual value of cosine of 31 degrees is 0.857167. So notice it is actually a very close, even correct to 3 decimal places.